Class, I thought I would post a couple things that may be helpful to you. You might already know this, but just in case some of you might be confused. On the assignment today, where we're dealing with composite shapes, I want to make sure you're aware. Some of these diagrams are obvious. You can look at number 7. You can see it's a cone, and then there's a smaller cone being removed. So you are subtracting the smaller cone from the bigger one. But some of these drawings look a little bit more confusing. So your general rule in the textbook is this. If you see a shape drawn inside of a shape, that means you're cutting that out or subtracting it from the bigger shape. So in this case, we have a cylinder, and we are removing from the cylinder this cone on the inside. So you're subtracting the cone from the cylinder. Looking down the road to other diagrams, again, you can see on number 9, this composite shape is we're adding a cylinder to a cone. Here, we're finding the volume of a cone, and we are subtracting or cutting out of that the cylinder. So again, when you see shapes inside of shapes, it means you are removing the inside shape from the larger shape. There's the first part. And then you're not going to run into this until the next module, which is spheres. But in spheres, let me jump over to a little blank space here if I can. Actually, that's the best I can do. So in spheres, you're going to have a formula for the volume of a sphere, which is 4/3 times pi r. And now we're looking at a cubed radius, not a squared radius. So some of you may have questions of how to accomplish that with your calculator, and I'm not sure which calculator you have. But on the electronic one that's linked to your website, there's a key down here, a specific key for cubing. So if I want to do 5 cubed, there's one way to do it. The other way, which is much more general, is, and you can't see it on this calculator, but on typical calculators, if you look at this button right here, you'll see a little hat or an arrow pointing up. On a calculator, that typically means the next number you're going to see is the exponent. So if I wanted to raise the number 6 to the power of 12, I would use this key, and that will give me a little caret or a hat. And now the next number that I'm going to put in there, the calculator will interpret that as the exponent. This is 6 raised to the 12th power, and there would be your answer. So using that little hat or caret on your calculator will allow you to raise a number to any power that you want. In this case, you can cube it. The other question would be is, some questions on spheres are going to require you to find the cubed root of something. So if you ended up getting this final equation, 120 equals r cubed, you're going to have to cube root both sides, not square root now. Now you're going to have to cube root, and I got this kind of messed up here. Let me move this equal sign over. I want you to see a cubed root looks like a square root, but there's a little 3 here in the front to let you know we are we're cubed rooting. We're finding what number multiplied by itself 3 times gives me this number in the root or the radical. So cube rooting, 2 ways to do this. The first way is, in order to cube something, you would raise it to the power of 3. In order to cube root it, you would raise it to the power of 1/3. So interestingly enough, r cubed, if you wanted to cube the number 6, you would put it in your calculator like this. If you want to cube root it, you would put it in your calculator like this. So it's basically 6 raised to the 1/3. When you put a fraction as an exponent, it means you're finding a root. If you put it as a whole number or a decimal number that's greater than 1, it assumes you are raising it to an exponent. So there is one way to do it, raising it to a power of a fraction. So in this case, if I had the number 8, and I wanted to cube it, I would raise it to the power of 3. If I wanted to cube root it, notice I'm going to put this in parentheses so it knows that's my exponent. And you see now you get the number 2. 2 times 2 times 2 gives you 8. That is the cubed root of 8. That is the most obvious way to actually get something to be a root. So again, you can look at this class, you can experiment with this. If I do 9 raised to 2, or 9 squared, you get 81. If I do 9 raised to 1/2, this means, this number, this denominator, means you are square rooting it, and you would get 9. So that's how you can use fractions as exponents to find roots instead of an exponent number. All right, so that is the easiest way. There are some calculators that will have a symbol like this on them. They'll have, like for square root, it'll just look like this. For any root, it will look like this. It'll have a little X there. And what happens is, if you want to find a cubed root or the 4th root or the 5th root, the way you'd put it in your calculator, you would put in the root you want. Let's say you want a cubed root. You'd put in 3, and then in your calculator you would press this key to find the nth or the x root of something, and then the next number you would put in is what number do you actually want to find the root of. So if you did this, 3, and you press this key, and then you press the number 8, it would find the cubed root of 8. So hopefully that will help you. A couple different strategies. I personally prefer to just use the fractional exponent to find a root of something, and you'll need to know that next year very well in Integrated Math 3, so it's great practice to begin to use fractional exponents. All right, I hope that is helpful to you.